Welcome to the Explainer. So, if you've ever felt that awful knot in your stomach the second you look at a page full of math symbols, hey, take a deep breath. You are in exactly the right place. Today, we're creating a totally safe space to conquer that math anxiety once and for all. Think of me like your own private tutor, just sitting right across the table from you. We're going to ditch the heavy textbook jargon and rely on pure, simple visual logic. In fact, before we even think about looking at a single mathematical formula today, we're just going to look at some friendly shapes. Because, believe it or not, the math we're tackling today, it's the exact same logic your computer uses to calculate those sweet online shopping discounts, or how surveyors measure plots of land, or how architects map out massive building designs, even how your smartphone organizes its data storage. It's all the same stuff. Now, I want you to keep this thought in your back pocket as we go through things today. Math is really just a way of organizing everyday logic. Let's draw it first. That right there, that is our golden rule. When we hit a tough problem, we are not going to panic. We're not going to desperately search our brains for some formula we have remembered. Instead, we're going to draw it out. We start with the visuals, simple shapes, basic patterns, because when you actually understand the logic behind why a concept works, I promise you, the formula just naturally makes perfect sense. All right, let's dive into section 1, visualizing math without fear. Okay, so imagine a really common real-world problem. Think of a teacher just trying to keep track of who is absent in class over a couple of days. Sounds like a totally basic, boring administrative task, right? But mapping out those groups of students is literally foundational mathematics. We can solve problems exactly like this by just drawing simple boxes and circles. What we're looking at here are called Venn diagrams, or, just Venn diagrams for short. They are hands down one of the absolute best ways to represent groups of things, which, by the way, in math, we just call sets. Notice how it's really just a rectangle, which holds absolutely everything we're talking about, and then some closed curves, usually circles, that hold specific little groups inside that everything. And that's it. Boxes and circles. Nothing to be afraid of. Moving right along to section 2, the universal set and subsets. Let's break down exactly what this box and circle are actually doing. We'll start with an easy level example. What do we have given to us? Well, we've got a rectangle, and floating around inside it are the numbers 1, 3, 5, 7, and 9. But look a little closer, right inside that circle labeled A. Inside there, we have 2, 4, 6, 8, and 10. So the rectangle as a whole holds all the numbers from 1 through 10, but circle A has a very specific job. It is only holding the even numbers. And that brings us to our very first formal definition. That big rectangle representing the entire main group of items we're talking about, that is called the universal set. In math, you'll often see it labeled with the Greek letter mu, which kind of looks like a little U with a long tail on the front. Now, please, do not let that symbol scare you. It's not some complicated mathematical operation you have to solve. It's literally just a shorthand label. It's a name tag for the big box that contains our current little universe of numbers. Next up, we have the subset. A subset is simply a smaller group, like our circle A, that is entirely contained within a larger group. Now, why do we call it that? Well, think about it. All the even numbers, 2, 4, 6, 8, 10, are tucked inside circle A. But because circle A is inside the rectangle, those numbers are naturally sitting inside the big rectangle too. Because A is completely 100% inside the universal set, A is a subset. It's a subpart of the whole. Makes sense, right? All right, let's level up slightly. We're going to a medium difficulty example now. Look at this setup. Circle B is completely trapped inside circle A. Let's look at our givens again. Set A has 2, 4, 6, 8, and 10, but set B only has 4 and 6. Because 4 and 6 are inside B and the entirety of B is chilling inside A, B is a subset of A. In math shorthand, we write this as B, then this little sideways U shape, then A. That sideways U, it literally just means is a subset of or is completely inside of. See what we're doing? Visual logic first, shorthand formula second. Let's jump to section 3, the overlap. What happens when groups meet? Okay, so we've covered the big box, and we've covered circles trapped inside of other circles. But what happens when groups share some things, but not everything? Let's swap numbers for letters here. Set A contains A, B, C, and D, and set B contains C, D, E, and F.
And this brilliantly illustrates the overlap. Notice how the letters C and D are sitting right there in the middle, in that shared space between the two circles. That shared space acts like a bright highlighter, instantly showing us visually that C and D belong to both Group A and Group B.
Which naturally leads us to a really important question. What happens when we want to mathematically combine two totally different groups into one massive group? Like if we want to take everyone from set A and everyone from set B and throw a big party together, how do we actually write that out?
That brings us perfectly to Section 4, Set Unions, or Combining Forces.
Look, you already know the mathematical operation of addition for numbers, right? Like 2 plus 3 equals 5. Well, union is basically just the addition operation, but applied to groups or sets of things. The formal definition of a union of sets is combining all items from two sets into a brand new single set. The symbol for this is a big right-side-up U. Honestly, you can just think of the U as a big bowl that you're dumping both sets into, or just gathering everyone together into one place. But, and this is a big but, as we'll see in our next example, you have to be super careful about exactly how you count the people in that bowl.
All right, Section 5, we are going step by step through the attendance problem.
Okay, take a deep breath. We are now ready for a hard board exam level word problem. But don't worry, we are going to take this step by step using split screen visual logic. Now, first things first, in any exam question, you have to identify what is given. Let's read the problem together. Suppose A is the set of students in your class who are absent on Tuesday, and B is the set of students who are absent on Wednesday. The text tells us exactly who is in these sets. Set A, the Tuesday absentees, includes Roha, Ramu, and Ravi. Set B, the Wednesday absentees, includes Ramu, Preeti, and Hanif. Okay, boom, that is our given data.
Next up, we clearly state what is asked. The problem says, now we want to find K, the set of students who are absent on either Tuesday or Wednesday. Here's a pro tip. When you see the phrase either or in set math, it almost always means they want a union. We need to combine set A and set B to create our new set K. But here is step 3, and it is absolutely crucial. You gotta watch for duplicates. And this right here is exactly where drawing it out literally saves your grade. This purple overlap represents A union B. Now, if you were just adding blindly without drawing it, you might say, okay, 3 people absent Tuesday plus 3 people absent Wednesday. That equals 6 people. But no, that is literally the most common mistake students make in exams. Look closely at our lists. Ramu was absent on Tuesday, but Ramu was also absent on Wednesday. If we just blindly add the lists together, we count Ramu twice. And last I checked, he's just one guy. Visually, Ramu sits right there in that overlapping middle section, just like the letters C and D did earlier. So when we gather everyone into our big union bowl, we only write Ramu's name down once, meaning the final number of unique students in set K is exactly 5. Roja, Ramu, Ravi, Hanif, and Preeti. Oh, and wait, the text mentions a student named Akila. Is she in set K? Nope, because the text tells us she is always present. So she's just hanging out in the big universal rectangle, safely outside those purple absent circles. And finally, Section 6. Your 5-point set cheat sheet. See, you just solved a multi-step exam-level word problem using pure visual logic. Amazing. Let's wrap all these visual concepts up into a neat little package so you feel 100% prepared to tackle any question like this. Here is your ultimate 5-point cheat sheet. Number 1. The big rectangle is your universal set containing everything. Number 2, the circles inside are your subsets. Number 3, when those circles overlap, those are shared items belonging to both groups. Number 4, a union, that big U symbol, just means combine all the unique items into one giant list. And number 5, your surprise trick to save time and dodge those tricky exam traps: never, ever count the overlap twice. Always scan your list for duplicates before you calculate your final total. Just draw the Venn diagram, put the duplicate in the middle first, and you will literally never make that mistake. Man, we have covered a lot of ground today, and we did it completely visually. So I'm going to leave you with this final thought. If math really is just drawing boxes and circles to organize everyday logic, what complex problem in your own life can you map out today? Seriously, think about it. Thank you so much for joining me on this explainer, and remember, always draw it first. Catch you next time.